Yes, sir.
So first of all, we are moving towards class 10 science chapter number 5, classification of elements. The first question, why there was a need of classification? Why elements must be classified? The reason I have said, without the classification of elements, it would be extremely difficult and time consuming to individually study the chemistry of all the elements. Hence, to simplify and systemize the study of elements and their compounds, these elements are classified into groups and periods. Now, earlier elements were classified into two parts, metals and non-metals. But later on, when there was a discovery of an element which was having similar properties of metal and non-metal both, that time they had given a name metalloids. So earlier elements was classified into the three parts, metal, non-metal and metalloids. But in 1829, a German chemist John Wolfgang Dobereiner has given a Trades Law of elements. In this law, Dobereiner had arranged the elements into the increasing atomic mass order. He has said the atomic mass of the middle element is approximately the arithmetic mean of the other two elements present in the traits. He had given some of the elements as lithium, beryllium, boron. Lithium atomic mass 7, boron atomic mass 11. He had done the average mean or arithmetic mean 7 plus 11 upon 2, 18 upon 2, that is equal to 9. So 9 was the atomic mass of beryllium. Similarly, he has taken other elements as lithium, sodium and potassium. The atomic mass of lithium was 7 and the atomic mass of potassium was 39. He has done the average of these two atomic mass and he had get 23, that was the atomic mass of sodium. Similarly, carbon, nitrogen and oxygen and calcium, strontium and barium. But later on, some of the elements he was having approximately mean, and slowly as the atomic masses increases of the heavier elements, his Trades Law was failed. So the limitations of Dobereiner Trades Law, large number of elements would not be grouped into the trades as manganese, iron, cobalt, nickel, copper, zinc, etc. This was a very different because all the elements were not having same properties into the increasing atomic mass. Beryllium, boron and carbon was having different property. Lithium, beryllium and boron was having different property. Lithium, sodium and potassium was having same property. So it was possible that quite similar elements were grouped in the trades. Dobereiner could classify only the 3 trades successfully. But later on, this all has been failed. Now we are talking about the Newlands law of octaves. As there was a limitations of Dobereiner Trades Law, later on Newlands has given its Octave Law, in which he has introduced the Western music, which was similar to Indian music, sa re ga ma pa dha ni sa. You all may be knowing about this music system. So he has seen the first and the 8th elements are having the same properties, and these elements are arranged in their increasing orders. So he has given the law of octaves. So finally, at the time in 1869, the total 56 elements were discovered, and Newlands have arranged these elements according to the increasing atomic masses into the periods and groups as the Indian and Western classical building systems were arranged. So what he has seen that the elements which are arranged in the increasing atomic masses, the 8 elements resemble the first one. So what will happen if it is resembling the first one? As a result or conclusion, there is some symmetrical relationship between the order of atomic masses and the properties of elements. So this gives to a new term that's called periodicity. So Newlands was the first person who has given the word periodicity, but at the same time there were some limitations of Newlands octave law. So what are the limitations? Limitations of Newlands octave law. The first limitation, this law was applicable. This law was applicable for elements. This law was applicable for elements with atomic masses up to 40. Means till the 40 atomic mass, this rule was obeyed. After 40, the rules were disobeyed. Properties of new elements discovered. Properties of new elements discovered did not fit into the law of octaves. Means what the second limitations is saying, that later on there was a discovery of inert gases, and he had said there will be only 7 groups. So as the inert gas elements were discovered, so that time this law was failed, that it is not matching to the octaves, it is matching to the nonaves. Means 9 elements are matching, not the 8 elements. So that's why his second limitations were there. The properties of new elements discovered did not fit into the law of octaves. In few cases, third point, in few cases, Newlands placed 2 elements. Newlands placed 2 elements Newlands placed 2 elements in the same slot, to fit elements in the table. Why he had done? Because that 8th law should match. So I am showing you his table. You can see here few elements. Cobalt and nickel he had given in 1, strontium cesium and lanthanum he had given in one. So according to this, his law was also having a limitations that in few elements, the two elements were placed in the same slot to fit the time, fit the table. Now the third limitations I am talking about, third was already given. Now fourth one, he also grouped unlike elements under the same slot. The last limitations, he also grouped unlike. He also grouped unlike elements under the same slot. I'm talking about cesium and lanthanum. So these two also were placed, which were having different property. You can see here cesium and lanthanum. Lanthanum is a S block element and cesium is S block elements. So other properties were also grouped at one slot. The most and complicated limitation is that he had not left the space for the new discovered elements, and he had arranged in the increasing atomic mass. That was no doubt. He had given the word periodicity. That is also no doubt. But the limitations which were really sincerable, that are, he had not left the place in the periodic table that later on the elements can discover and it can get a place in its periodic table. So these were the few assumptions and the limitations of Newlands law of octave. How many of you are having doubt in Newlands law of octave? Let me tell you, there was some achievement of the law of octaves. The law of octaves was the first logical attempt to classify elements on the basis of atomic weights. Periodicity of elements was recognized for the first time in 1860. There was a conference of chemists in which Karl Struhe belongs from Germany, a young Russian chemist Dmitry Mendeleev, attending this conference, were deeply influenced by this presentation presented by Stanislaw Cannizzaro, who had described the Cannizzaro method for determining atomic mass of elements. After then, Mendeleev has started working on these aspects of atomic mass and periodicity, and later on, he had also stated the law of chemical periodicity. Defects of this law of octaves: this law could be best applied only up to the elements calcium, whose atomic mass is 40. Newly discovered elements could not fit into the octave structures. The feature of resemblance of the 8 elements when arranged in the increasing order of atomic mass was not successful with the heavier elements. After these all phenomena were closed, later on in 1870, the Lothar Meyer, you may have heard about his name, Lothar Meyer. Till here, Newlands chapter closed. Now we are moving towards the Lothar Meyer, which is specially not mentioned in your NCERT, but we should have a knowledge about it. Lothar Meyer's curve. Lothar Meyer's curve. In 1870, remember the date also, year also. In 1870, that time also, the total 56 elements were only found, and he had plotted a graph which was against the atomic masses to atomic volume. He had just made a graph which was different than atomic masses versus atomic volume. He has made this type of graphs in which he showed that some of the elements which are on the top are specially having high melting point and boiling point, which are having at the below and the bottom of This graph are having low melting point and boiling point. In this graph, he had just mentioned that the volume of the elements are against their atomic mass. Volume of the elements are against their atomic masses. So this thesis was developed by a German chemist whose name was Lothar Meyer, and he had given this diagram. After them, there is a great study about a new scientist called Mendeleev periodic table. It is really a new amazing thing about Mendeleev. He is the father of periodic table. You might be knowing about him. In 1869, remember dear students, and later on, not only 69, slowly, you maybe have heard that there are some elements which were discovered later. This 1869, till 1869, 56 elements were discovered. And when the Mendeleev have started, that time, the total 62 or 63 elements were discovered. So what he has classified, the elements on the basis of physical and chemical properties in the order of increasing atomic masses in the form of tables. Mendeleev have observed that properties of elements orderly recur in a cyclic fashion. He found that the elements with the similar properties are at regular intervals when the elements are arranged in the order of their increasing atomic masses. He concluded that the physical and the chemical properties of the elements are periodic functions of their atomic masses. This came to be known as the Law of Chemical Periodicity, and he stated that the physical and chemical properties of the elements are the periodic functions of their atomic weights. Let us give a topic name, Mendeleev's periodic table. So let me tell you what he had stated. He stated that the physical and chemical properties are the periodic functions of their atomic weights, or the periodic functions of their atomic weight. This statement was given by the Mendeleev periodic table, and he has arranged the elements in the form of periodic table. Elements were arranged according to the properties at a regular interval and fell into the several certain groups or families. These elements in each group were having similar many properties, and the elements which were having dissimilar properties were separated from the groups and periods. Mendeleev periodic table contained 8 vertical columns called groups and 7 horizontal rows called periods. Each group had 2 subgroups, group A and group B. The properties of the elements of a such group resembles much more markedly than the properties of those between the elements of those sub-2 groups. Let me tell you, The achievements of Mendeleev periodic table. Mendeleev periodic table was one of the greatest achievement in chemistry, with some of its important contributions. Mendeleev periodic table simplified the study of elements as the arrangement of elements showing the similar properties which were classified into the groups. It was very useful in studying and resembling the properties of a large number of elements in a symmetrical way. You can see the classification of Mendeleev periodic table, which is represented in your NCERT textbook. All of you are having NCERT textbook? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
All of you are
Sir.
having NCERT textbook. Just open your NCERT textbook and see the Mendeleev periodic table.